Hello, I'm Christopher Fowler, and today I'm doing a presentation on project number 10, the race car project. We are doing this project because JJR is in a slump in the racing industry, and they are looking for race car design to help get them in the winner's circle. They're looking for an engineer who knows aerodynamics and the effects it can have on a vehicle. In the process of developing this project, I followed the engineering design processes, and the first of these steps is identifying the need. In this case, JJR is going to hire automotive engineers to design and complete small-scale models of race cars, with the hopes to create a full-scaled race car that can run on CO2. First, JJR would like engineers to use Autodesk Inventor and Flow Design to test the modeled cars in a simulated environment. So my goal is to design a CO2-powered race car that has excellent aerodynamics, to come up with a design concept, draw two rough hand sketches of possible designs. From those, choose a final design and perfect it. Draft the final design, and create working drawings. Have the design 3D printed, then assemble and race the car. Next, define the criteria. There were certain guidelines we had to abide by when designing our cars. We had to come up with a design that falls within these size constraints, follow required axle placement, use only provided parts such as tires, axles, eye hooks, and CO2 cartridge. Create working drawings. Have body of car 3D printed from the drawings. Assemble the car. Race the car. Make any changes based on the race results if needed. Next, explore, research, and investigate. Here we are in the research portion of the engineering design process. So we research design ideas that we came up with and concepts or car styles. Research and develop an understanding of how aerodynamics play into and affect car design, such as laminar flow, turbulent flow, drag, and lift. We then use the research to design the best car you can and try to maximize the aerodynamics of the car body. My sources are listed here. Next is to generate solutions. At this point, you want to have a general idea of the direction you're going to go with your design. I thought, who better to perfect an aerodynamic car than a sports car company of today that manufactures sports cars. Also, I'm just a fan of how they look. Based on research, we needed to create at least two hand-drawn sketches. I based my two designs on Ferrari and Nissan 370Z. I figure Ferrari and Nissan had done plenty of research on the aerodynamics. I was wrong. Next is to come up with a final solution or design type or idea. Thanks to the steps in Generate Solutions portion of the engineering design process, I realized I needed to go completely opposite direction. So I went back to the Explore, Research, and Investigate steps after having a thought about soapbox derby cars. After a little research, I realized they are attempting a similar goal, just on a bigger scale, and using gravity instead of CO2 for power, but aerodynamics are still crucial. For my final design, I went in that direction. I designed my race car based on a soapbox derby car style that had good aerodynamic flow, our cars are all going to use the same power, so it will come down to weight and aerodynamics of who wins the final race. So I did a new rough sketch after a little more research. I then created my working drawings based on this design. The pictures are listed here. I found aerodynamics is a huge part of the hobby, so with all that, I decided this was the direction I should go with my car design, so I began redoing my drawings. Next is detailed design. With my new design locked down, I began the steps to creating my working drawings, 3D models, and a file for the 3D printer. I started with hand drawings, then created working drawings off of that design, and I did working drawings of the parts. Then based on the hand drawings, I created a complete set of the working drawings in Inventor as requested. See the next two slides for images of those drawings. Next is model, develop, and produce. At this point, we gave a file to the Maker Lab at a local school to have our car body 3D printed. Once we received our car bodies, it was time to assemble our cars. First, my axles needed to be cut down to accommodate the design type for my car body. Also, trimming the flashing off of the plastic wheels so there were no lumps or rough spots. Next, it was time to test and evaluate. It was time to race. So we could test the performance and collect data. My car weighed 134 ounces. We raced them a distance of 100 foot. My car was unfortunately eliminated the first round, but it was a close race. Next, it was time to make improvements and redesign. Based on our race results and the research done on flow design, my car would benefit from a weight reduction. The car that beat mine and won the overall race weighed only 114 ounces. The aerodynamics testing done in flow design showed it was a very aerodynamic design though. Thank you for listening. And in conclusion, I found it to be a fun and educational project. I was already into cars, but now I know more about what goes into designing them. I also learned a lot about aerodynamics and how big of a role it plays in a car's performance. It was a challenge for me trying to design a car that performed well, following the design restrictions, but that I also thought looked good. If I could do it over, I would definitely try to save as much weight as possible, because I feel that was the main difference in each car's design. We all followed the same restrictions, had the same CO2 cartridges, and did aerodynamic testing, so it really came down to weight and aerodynamics. We also now have real-world data to support this theory, because the winner of the overall race was also the lightest car built in the whole class. Again, I'm Christopher Fowler, and thank you for listening. I hope you enjoyed my presentation.